So here's our next problem that's tipping and slipping problem. So we have is a cabinet. It's 2 feet wide. The center of mass is in the left to right is in the center. It's 3.5 feet up off the base of the feet. And there's going to be a force here, 35 pounds, that's applied. We're given the weight of the cabinet is 150 pounds. We're given the friction coefficients at the base. And we're asked determine the acceleration for the center of mass of the cabinet, the angular acceleration, and the support forces. That'll be A and B. All right. Now the problem here is we need to figure out, is this thing tipping or slipping? What's the mode of motion? So let's just take a quick look. Here's the free body diagram. Here's the weight. 150 pounds coming in, the 35-pound force that'll be applied to the cabinet. Note that we have separate forces here for the supports because there's going to be a leaning tendency, so there'll be more force most likely in one or the other. Hence, there'll be separate friction forces associated with each one. And let's get started. So what I'm going to do is, I understand here the force that's going to be applied is 35 pounds, but what I want to do is figure out what is the form of motion. Are we tipping? Are we slipping? And so I want to find out what is the force that initiates motion. So yes, it's 35 pounds, but what I'm going to do is treat this thing as static and figure out what is the force just to get something started, and when it starts, which one is it, tipping or slipping, and then I'll go put that in. So looking at this statically, if I sum forces in the x, we have P coming across, which is now a variable, minus the friction forces. Summing forces in the y, it's obviously not moving up or down. So we have NA plus NB, the support forces, minus the weight. All right. And if I look at this from this force, if it's going to tip, that's going to be happening at B here at the bottom. So it makes sense to take the moments about B to see what's going on. So taking the moments here, that wipes out NB. So I'll have NA times 2 feet, and that's going clockwise. So we have that one. And based on P, that would also take us clockwise. So, and it's 4 feet up relative to B. So that's minus 4 times P. And then, of course, the weight, which is 1 foot offset from this corner, would be 150 times 1 positive. That's going counterclockwise. All right, so let's assume that this is going to tip and see what's happening. If it's tipping, okay, then what that says is that just before it tips, all the weight would be on B. There would be no support here at NA. All right, so if we go with that, that says that FA would be 0 right here. And FB max, so if NA has 0, then the friction from here would be 0. Okay, and we have all the force here at NB, all 150 pounds. So times 0.2 for static friction, that says FB max available is 30. Okay, which says the maximum force up here, if this is going to be 0, it says P max is 30 pounds. Okay. But if we have tipping, what do we get? Let's go to this equation. NA is 0. And so if we solve for P, to get to tipping, we need 37.5 pounds. Okay. So 37.5 pounds minus the 30 pounds that's available. So this is what P would be from this equation. Minus the 30 that's available, what do we see? It shows there's not enough friction there to stop it from sliding. So we'll already be sliding. So what we found from doing this is that to make a tip, we need this amount, but we don't have enough friction to hold it back. So it will have already have been slipping. Slipping is the mode that's going to get us going. All right. So slipping or sliding. I use the word sliding here. All right, so we know we're sliding. So let's go based on that. And so Now we put in our 35 pounds. Okay. And so we're sliding. So now for here, the force of friction, it's kinetic, it's sliding. So we have 0.15. We're using UK, NA and NB. And that'll give us the acceleration in the X. We're sliding, so there will be no vertical acceleration. So this is just equal to 0. And then if we take the moments about G, that's just what we had before. And because we're sliding, we're not going to have any angular acceleration, so alpha is 0. So we have basically the same equation we had before with a few changes. So let's see. 35 relative, if I take the moment at G instead of B now, I have 35 pounds coming in, and the vertical distance here would be 0.5 feet, and that's going clockwise. There's a negative. NA, relative to this point, that will be going clockwise, so that's 1 foot off. Relative to the friction here, that would be 0.15 NA, and that's 3.5 feet up to get to there, perpendicular distance. At NB, it's on the other side, so NB is 1 foot off, and that would go counterclockwise, that's positive. And here the friction will be NB times 0.15, and that's 3.5 feet down, and that has a clockwise orientation. We have 3 equations, 3 unknowns, solve. We get the acceleration along the X is 2.68 feet per second squared, and NA and NB are as given here. And you'll know NA is smaller because with this force, it's putting more of the force in the back side or the B side as opposed to the A. Now, it wasn't asked for in the problem, but on the bottom I actually took this just a little bit farther and said, what is the P necessary for motion? Okay, so 35 definitely gets it sliding. What's the force it takes just to get us barely moving? All right, so this is, we want to find out the point where we're just at the point of getting motion would be where the force of friction is mu(s) times the normal force at A, and mu(s), the static friction, times the normal force at B. So when do we get that full effect? All right, so if NA plus NB minus 150 is 0, it means NA plus NB is 150. That says the maximum friction available, static friction, would be 0.2 times 150. So 30 pounds is the maximum available of stopping force along the x-axis, which says P. If we go up here, we would need P minus FA minus NB. These are, most are 30, so 30 minus 30 is 0. It says the force to start motion is right here at 30 pounds. If we use that and stick that into the sum of the moments, we find at that point we would have NA is 15 and B is 135.